Hello. I suppose the easiest way to deal with this is for me to just do a video. As much as I hate talking on videos, especially with these cameras, because I'm looking at me and the camera's over here somewhere. So I'm afraid you have to put up with my monotone voice and just, if you want to make a Lazer ZXR, I suppose some of those people experienced enough to just do it will probably just do it their own way. But I thought I'd do this. It's probably going to help people. I would say, as I've been 3D printing for a few years, I would say this is probably on the more advanced side of stuff. But you've got to know which way around to put things on the plate. And unfortunately, I'm not going to be able to tell you exactly how to do that because it depends on many factors, like what printer you've got, what filament you're using, how how your settings are. There's so many settings 3D printing. If you've been through the advanced settings, you know what I mean. Probably the best way to do it is to just try a few different things out. Some things are going to be easy to print. Some things are not going to be so easy to print. And obviously, you probably if you've got a big enough 3D printer, you can probably 3D print every part of this car. Whether it will be usable after that point, I don't know. My 3D printer, I've got a Creality K1 Max. That's got a 330 by 330 bed, and you could probably, I don't know, maybe just about squeeze the chassis on there. I've not tried. Most of these things, it doesn't mean because it's got a 330 by 330 bed that's the size you can actually print though. Because obviously that with a lot of them, that is the physical area of the bed. So obviously with the restrictions of where the head can move to, that might mean you can only print 300 by 300. I don't know. So if you could 3D print a chassis, with a good filament, perhaps you'd be able to create a car with it. I use a CNC router, which I've recently bought a new one, bigger one. Again, I had a 3040 that was not 30 centimeters by 40 centimeters by, if anyone's seen my first car that I made, the carbon fiber is at a silly angle. That's because I had to put it at an angle on the bed to get it to cut it out. So realistically, you need a printer that's got clear, or rather a CNC router that's got a clear, large enough space to be able to move its head around and cut a chassis out. So the chassis is 328 millimeters long. And that regardless of whether you're doing the ZXR Mark 1 or ZXR Mark 2 or ZX, they're all the same length, 328 millimeters long. So the chassis that I'll upload are just the standard chassis. I've not done any modified chassis for it. I'm halfway through doing one, but in all honesty, I just haven't had the time recently to sort that out. So maybe I'll upload it later. But at the moment, for the car pack and everything else I'm going to do, your original chassis, you've got Mark 1 ZX, ZXR, and you've got Mark 2 ZXR. Two, both slightly differently. You can't interchange the two. So if you're using a Mark 2 ZXR, you would need the Mark 2 chassis, Mark 2 motor plate, and Mark 2 top deck. You can't interchange the two. They're different sizes. The holes are in different places. They won't fit. Everything else, within reason, is pretty much is going to fit. Now, I've tried doing this video 2 or 3 times in the last week or so, and it takes it's a 2-hour video every time, however I do it. I'm hoping this is not going to be a 2-hour video, so I'm going to try and rush my way through it a little bit. So at this point, I will say, if you don't know what you're doing with 3D printing, go away, learn 3D printing first, as much as you can, and then come back, because some of these things are going to mean something to some people, and if you're new to it, they're probably not going to mean an awful lot to you. So I've been 3D printing for a few years, and it still catches me out in some ways. So let me turn the camera around. So excuse the carbon fibre. This carbon fibre was sold to me as red. It's not red at all. It's more like rose gold or salmon pink, but this is what I've got. So I've made quite a few cars now, and I can just keep making them, actually. One of them's downstairs at the moment, but there's this one up here, which is completely 3D printed. That's a completely 3D printed Mark II ZXR. This one here is probably only 2 or 3% 3D printed. There's mostly original parts, and that one there is an original 1994 Mark II ZXR. I have a Mark 1 downstairs. I'm currently pulling apart and working on doing these parts for you guys. So where to start? Basically, this is the chassis that I've cut. This was cut out yesterday. I'll put a photograph of the other one. I've just cut out a Mark 1 chassis, which has the extra bit here. It's like for an extra cell. I've cut that one out yesterday, so I'll put a photograph in somewhere around here with that on. But the Mark 2, this is a Mark 2, and this is a Mark 2 top deck. This is a ZXR steering. I don't know what you want to call that. I don't know what they call it. Steering arm, steering parts. I don't know. So obviously they don't come from factory with bearings in. I've pushed them in there. I've done some of the holes I've done in these. Well, you won't be able to push a bearing in it until you've reamed it. So if I made the hole too big, then you can't do anything with it. If it's too big and you push your bearing in and it just falls out because it's too loose, and there's absolutely no point to it. So what I've done is I've made all the holes slightly smaller, so very, very tight tolerance. So that would mean that you'd need to run a reamer through it, or a 6mm drill bit carefully, which just means that everything will fit better. So them bearings I've pushed in there and they're a tight fit. All I did was ream the holes out with 6mm. These end holes here in the instruction manual for the ZXR, they are actually threaded. So I believe I've made them 2.8mm. Don't hold me to it, but they are definitely small enough to be threaded. I normally run a 2.8mm drill bit through it first, then thread them. You can buy 2.8mm off of Amazon if you haven't got one, or anything like this here. These are from, I don't know what country you're in, but in the UK, this is Lidl. They sell all these sort of things in the centre aisle at Lidl, and these particular drill bits went from like 2mm to 3mm in 0.1 increments. So anything like that's useful to have when you're making stuff like this. So this is model making, obviously. This is not just, buying a kit and putting it together. You're going to have bits that you're going to have to do. So what I've lined up here is I've got this here, which is an original part. That's the original top deck mount. It comes in two parts, you see. That's the original one, and this is the 3D printed one that I've designed. I've tried to be as accurate as possible. That's just me. I obviously didn't have to do all this in the back of it, but I can't help myself. I just think if you're not going to do something properly, don't do it at all. So I've tried to make it as close to as original as possible. So looking at it, the only thing that obviously gives it away is the layer lines. You can see layer lines in it. Now I have ironing switched on all my parts, because why wouldn't you want it to look as neat as possible? So for instance, the spur gears there, the left one is the original, the right one is 3D printed. You can see it's fairly smooth, the 3D printed one. But this has been made completely with measurements. I don't have a scanner or anything like that. This is all made with measurements using a vernier. As you can see, they do mesh. They mesh perfectly. The gears are spot on. It's exactly the same. I can do it with one-handed. So it's exactly the same. It's the same size, same width, the same shape, the same everything. It's a really good, actually, really good rendition of a Lazer ZXR spur gear. That one. These I've included the file. You can, if you've got a laser cutter. I don't know actually. My laser cutter isn't powerful enough to cut this out. So all it does is it marks it, and then I use scissors. And to get these round enough, I use a leather hole punch. But this material, which is obviously a high temperature gasket material, which is used for the slipper clutch for the spur gear, and if you can see, I'll put it on the 3D printed one for now, but it's a pretty tight fit. Once they're on, they don't fall off. So if you use the templates that are there, that'll do you. They'll be perfect. You can make as many as you like. And all I did was, I've got my one of my old 3D printers has a laser attachment, and I've used that just to mark the stuff and then cut it out. And it's just, this is my old Anycubic. Don't really use it anymore, but as you can see there, that's what I did. With it there. It just helps you get the pattern right, so it doesn't look a complete mess. But like I said, if you've got a powerful laser, you might be able to actually properly CNC cut it with that. I don't have an original motor plate for the Mark II to show you at the minute, although they're all on the cars. But this is a 3D printed motor plate. You know what? It's pretty solid. It's That's made out of ASA. You could probably use it, but I don't know how you get on with the heat of the motor. This I only 3D printed this to show you that it's included there, but I'm going to probably make one of these out of carbon fibre or aluminium. I haven't decided yet. This is the spacer plate that goes in behind it. So I have favoured the Mark II motor plate because it comes already made with the holes in to move the motor up and down, whereas the original, it's just a hole in here and you have another plate that screws on the back. I never had one of those because the first car I bought was a Mark II. So I've done both the Mark I and the Mark II motor plate like this. So it doesn't need the spacer plate. The only thing that means is obviously if you don't put this behind it, your motor shaft will stick out a long way. So I'd put that behind it. But anyway, this is a cutout one. CNC cut. That's 3D printed. So here, this is a black carbon fibre. This one is 3mm. This is the opposite side. That's the side plate, and I've done one with the tensioner for the Mark II. Again here, this is an original side plate for a Mark I or a ZX, and I've done one with the tensioner on it. So it should be that way up, but yeah. So that's the top there. That's the tensioner part. I mean, if you Google it, you should be able to see. I've not fitted those yet. You should be able to see what bearings and stuff to put on it. You need something with obviously a 3mm internal diameter and probably like a 6 or 8mm, probably an 8mm external diameter up to about 10 maximum, I'd think. And then you can have, I'd probably use a flanged bearing. Put the flanges on the outside, 2 bearings facing each other with the flanges on the outside. And then you just put something like a 30mm screw through the hole here with a washer either side, and maybe some spacers to get the bearings in the right place. Put a nut on the end. That then will give you a tensioner. Be able to tension your long centre belt. Yeah, these are. This is the original shape of front mount, which came with my Mark II when I bought it from the factory. So I just did an original one, but there are some others in there. Some others in the pack, like this one, for instance, which has a built-in brace at the top. And there's 2 different types. This one has, most people would probably think this is a bit stupid, but I cut this bit off the body and then fit it with a pin here. Some people don't want it, so there is one without that. So you just do away with the nose cone. I don't personally like having the nose cone on there. You might not. If you don't, then just cut out whichever one you want. Well, let's face it, with these files you can cut out as many as you like. Just keep going. Have a whole stock of them if you like in stock. So gearboxes. I'm using the ZX diffs. These are geared because the slipper ones are so hard to get hold of now. I did make one actually out of Optima parts, but it's a bit silly. It's a lot of hard work when these are just, you know, they're available. I'm sure I'm not racing. I'm not going to be racing the cars. So to me, it doesn't matter whether it's a slipper or not. I'm just making these things and tinkering, you know. So you've got an original rear gearbox and a 3D printed one. And the only thing with this one is when I got this one, it was missing this little cover. So this is a 3D printed cover on an original gearbox. Now, like I said before, I've done this video about 3 or 4 times, and when I first started doing these videos and trying to do these videos, my gearbox wasn't quite right. Whilst all of these parts were 99%, this piece here was wrong. So where this lump is, this was too far back. I've now moved it slightly further forwards, so now it fits the original gearbox perfectly. So now this part, this little cover, should fit, well, as you can see, it fits the original gearbox now, whereas before it wouldn't do. It all fits. This one is, like I said, completely 3D printed. It's as close as I could get to the original. I'm not claiming it's perfect, but if you're trying to build a Lazer ZXR, you need a rear gearbox, and that is, well, as you can see, 99.9%. Now this little cover, Now, you have to excuse me, it's got a little pin in there, but that pin is wrong. I put that in there because that's the only ones I had at the time. The nailed bit gets in the way of the roller, stops the roller from going round, so I shan't have that on there. I've ordered some straight ones. Those shafts, actually, these little pins, they're 3mm by 8mm, 8mm long, 3mm wide, and you need... these are wrong, actually. These little brass rollers, these are wrong. They sent me the wrong ones. I ordered the right ones, and they've sent me wrong. So they need to be 3mm internal diameter, 6mm external diameter, and 5mm wide, not 6. So they've sent me 6 wide and 5 out of diameter. It's totally wrong. But I've reordered them, so hopefully they'll get it right this time. Then the bearing, if you can see, this was only 3D printed. It's quite a tight fit, but the bearing just pushes in all the way up, and it's flush. So that's spot on. Now, all I'm going to say with these is this is what I'm saying about printing things the right way up. It matters. So I printed this like flat, like that. I've strengthened this slightly, otherwise every time you 3D print this and you take the supports off, it will break off. So I put this, raise it up about 3 or 4, 5 mil off the bed, print it like that, and then just spend a bit of time picking all the crap out the inside of it, because otherwise, if you print it, I've printed it this way a few times. The hole is never, none of these holes are ever perfectly round. So print it that way, like that, and print it slowly. Don't print it too fast. Just a quick note on what I'm using. I'm using ASA filament. I've used polycarbonate. So this entire car here, that entire car is polycarbonate. 3D printed out of polycarbonate. Even the spur gear. Now, polycarbonate, whilst polycarbonate is a really, really, really strong, really, really good filament, it's brittle. So if you're actually driving the car around in your garden or wherever you're driving the car around, you can decide to give it a race. The minute you touch anything coming in the opposite direction or something stationary, it's going to break. It's going to crack. You're going to have bits all over the track. So my opinion, ASA, which has probably a better strength than ABS, but slightly less impact resistance. ASA is probably about the best you're going to get, really. But you need a printer that's got an enclosure to be able to print that. Print ASA or polycarbonate, you need an enclosure. My Creality K1 Max will print ASA. It can be hard work because it doesn't like to stick to the bed. So, you know, glue and God knows what else I have to put on it to get it to print. It does eventually print, but sometimes it takes 2 or 3 attempts to get something to print. Normally because you need a higher temperature. I'm printing ASA at 280 and my bed is 100 degrees from the get-go. Whereas if you use the standard settings quite often will have you start at 60 degree bed and then it'll have you start at something like a 260 degree hot end. It's not hot enough. It's not. It comes off the bed. It doesn't even stick to the bed. So glue or no glue, I always start it off. I change the settings. I start it off 280 all the way through, 100 degrees all the way through, and then it prints absolutely no problems. But sometimes, once or twice, I've gone to do that. Even with those settings, it's not stuck to the bed. And in my opinion, it's because the chamber isn't warm enough. Because obviously when you start, it's stone cold. I think it's less than 30 degrees when I start, even with the bed set to 100. So I am, you know, if that happens, then when I reprint it, I go start it again. Usually then it works because the chamber's hotter. So if you've got a heated chamber, specifically heated chamber, this is going to be easy for you. You're going to fly through this, absolutely no problems. I tell you what, even if you could print PA12 or PA6 nylon, this would be the best thing ever. You'd be racing this car. It'd be the easiest thing you've ever done. I can't print it. I've tried printing PA12. My printer won't do it. Yeah, it's a mess. It's not going to happen. So for me, the best I can get with my normal sort of home 3D printer is ASA, and you know it comes out really nice. It prints really nicely. Everything, as you can see, You know, the left one being the original, the right one being the 3D printed one. It's printed really nicely. I have no problems at all with printing everything in ASA. Again, the front axle box, that's ASA. So the left one here is the 3D printed one in this case, but if you can see, that's ASA. I think it's printed it really nicely. I think this one I printed open end up, because you don't have to pull all the supports out. If you print it open end up, there's no supports in there. A few supports on the front of it, obviously, but yeah, it's printed really nicely. So that's the original. That's an original LA32 axle box. There'll be a few people drooling at the moment because these are rare. I've got about 5 of them, but this is what I've done here. As you can see, these have a roller in the top which weakens it. So I have actually done a roller delete version, as you can see. No top roller. Now I'm not going to claim that it makes it really strong, because it doesn't. It makes it a little bit stronger than the standard. Now if I was to put that differential in there, obviously one-handed because I am recording this with a phone, it fits in there perfectly. Goes round, and I'll try and do this like this. As you can see, it lines up perfectly. So the belt will exit. There'll be nothing sort of rubbing on anything. It's a perfect fit. And I mean, I can print these all day long, these axle boxes. And as you'll know, if you know anything about lasers and Lazer ZXRs, they are hard to get hold of. These axle boxes, really hard to get hold of. I've bought everything that I've seen that's come up on eBay. But if you're missing one, or you want to print some, you're racing, you keep breaking them. Other than the fact that there's now, you know, Rubrix Racing are now selling aluminium ones of these, alloy CNC cut ones of these, which are amazing, I've got to say. I'm a little bit jealous. Haven't been able to afford one myself, but if you want one, they're the best ones, the aluminium ones. Buy an aluminium one and then 3D print the rest of it if you want. But these, you know, this is as close 3D printed, home 3D printed as you're going to get to the original. As you can see, it's absolutely bang on. This is an original one. It's absolutely no different to the one that I've 3D printed. And I could go downstairs right now, 3D print as many of these as I wanted. It's not difficult with these files. So the gearbox, again, like this gearbox, the rear gearbox, this is the 3D printed gearbox here. Normally goes in that way, doesn't it? For the belt. It's really difficult to do this on a mobile phone, but my GoPro, the sound for talking is horrendous. I don't know why. Now, you put this together, put it on here. There you go. Bearings are in. And try and get some light in there. As you can see, it's great. There's no catching, there's no issues. And yeah, once that's in and your belt's in, obviously you've got your bearing that goes in the other side of here. Which again is the point with these, is if you it depends how you print this. If you're going to print this, if you're going to print it open end up like that, and you print it slowly, you shouldn't have an issue fitting a bearing in there. But if you're going to print it up like this, you're going to have some plastic in there as a support. You're going to need to Dremel it out. The same for screw holes, really. All your screw holes, obviously this is like amateur stuff, really. If you're printing like this, all of these screw holes in here are going to be absolutely fine to put a screw in. You need to heat them up with ASA. You need to heat all the screws up. You need to heat the part up. I'd put it in boiling water, give it a minute in boiling water along with the screw, and then they'll screw together. And then once you've screwed it in once, you can take it out, put it in as many times as you like. If you were to 3D print it like this, however, or this, and you then put a screw in it, because of the layer lines, you're going to split it apart. You're going to break that apart. I have printed it like that, and I have put screws in it, but in polycarbonate. I've not even needed to heat the screw for polycarbonate most of the time. But you are running the risk that if you do it that way up, you're going to end up splitting the layer lines apart. So I would always suggest, if you've got a screw that's going to need some sort of structural strength to it, print it flat on the bed like that with the screw hole facing up, not like that. And that's where with these axle boxes it's important, because so these at the back of this rear section, these two, there's as you can see, there's not a lot of material around that. So this is from my textured PEI plate. So as you can see, I've printed it up that way. Now there are some screw holes that face forwards. Some people have said to me, "Oh, you know, print it at a 45-degree angle, or so many, you know, this much of an angle." It makes absolutely no difference. You can print it at any angle like this. It'll still split apart. You need to heat the screws, and you need to heat the part. But the ones that are most important on this axle box are those two holes, because of the lack of material. Now, I have done one where these are slightly bigger, but what you'll find is that they get in the way of this bar. You don't want to be in the way of this, because that's your steering then. There's no point in putting bearings in there if you're going to restrict it with pieces of plastic. So, my opinion, the rear part, at the very least, wants to be printed upright like that, and then you're going to have to spend some time picking supports out. But if you don't do that, you're never going to get the two screws to go in through the bottom. And obviously, they're the screws that go in. I haven't dug these holes out. Them screws, they go through the chassis, through these two holes in here, and then up into there. The 15mm screw. I would just be a bit cautious with them. Like I said, anything you're printing out of ASA, heat it. So something else I discovered as well, when you're printing out of polycarbonate, when you're putting screws in like this here, put the screw in, screw it in a couple of turns, and then wind it back out again, and then keep doing it. Every time, go in another couple of turns and wind it back out again. And what happens is friction heats up the screw. Screw gets hot, and then you're less likely to end up with a crack. I'd start off with it in boiling water first, and then, you know, do that with it. If you crack it, you can always 3D print another one, but I've probably had one out of all of the ones I've printed of those I've cracked, and I've done it on purpose. So this one I've just wound a screw into it. Just, you know, this was a scrap one anyway. I've just wound a screw into it, and it cracked straight away. But then this screw, can't get it out. I could do if I tried really hard, but it's starting to strip the screw. This is polycarbonate, and this stuff is really tough. When you put the screw into polycarbonate, you see how close that is to the edges. I would, with stuff like that, when it's really close to the edge like that, heat the screw, heat the part, put the screw in again, and then wind it in, wind it out, wind it in, wind it out. But if you do what I did with this, and you just force it in, it'll get to a point where it's really, really difficult to screw it in, and it won't go in any further. And then you're going to struggle to get it out. I could probably get that out with a pair of pliers, but that's how tough polycarbonate is. It's really strong. This was a failed print anyway. It's just a test that I did. But this part matters how you print it. Like I've tried printing it like that. Never goes very well. Best way I've found to print it is to print it like that, because this matters. This hole that goes through here, that matters. If you print it like that, raise it up off the bed, that's the best idea I can give you really with that. What else we've got? Front bumper. Yeah, that's my front bumper I've done. This is an ASA one. Works really well. Not easy to 3D print because of the shape of it. Raise it up off the bed, print it flat like that, and then raise it up off the bed a little bit. Should print just fine. These here, these are originals. Everybody knows what these are because they're one of the parts of the ZX and ZXR that they're really hard to get hold of now. They're so you know, they're so difficult to find. But you can see there's not a lot of material around that, and you've got to squash a 5.8mm ball in there. So that's an original part, like I said. And then the original size ones that I've done, which are obviously included in all my files, are there if it focuses. That's an original size one. Come on, focus. But there's not a lot of material around it. So the way I've designed it is I've designed the top to be slightly more open than the bottom. That doesn't mean that it's going to be weak and it's going to lose the ball, because it won't. But I would heat this first in some boiling water, and then heat the ball in some boiling water, and then put a little bit of Teflon grease on the top here. Use a pair of bullnose pliers, such as those, to squeeze the ball in gently, and it will click in. And when it goes in, it should be, you know, it's not going to be loose, but it's not going to be so tight that it's unusable. So I've also done some beefier ones, so to make it slightly easier for you. So as you can see, there's a bit more material around that, look. And the ball is in there, and it moves freely in there, look. That ball moves freely in there. Absolutely no issues. It doesn't fall out, it's not loose. So there you go. I would print, it's up to you. If you're one of these people like me that likes everything original, you can fight with these if you like. I would print these, let me find a black one, I'll find an original one. Print these up this way, like this, with support underneath. Yeah, because you need this to be strong enough to take the ball. And then the hole in the back, I would run a 2.8mm drill bit through it and tap it with a 3mm tap. So steering parts, these hubs here, these are original ones. As you can see on the original ones, it's got a mark there which says L for left. You see that? It says L for left. So my very nature, of course, is to repeat it as much as possible. These are failed ones that I did, but underneath there is an L for left. So what I was saying about supports, these are a really difficult one to print. I print mine like that. I print them like that. And then just use support underneath it, support ironing and everything to make it look at least half decent. But you can, as you can see, because it's printed like that, you're going to get some plastic sag down into here, and you can see that it's slightly square. So all you got to do is Dremel it. Just Dremel those bits of support out of there so it's round again. Don't do it so much that the bearing's loose, but you can use it to your advantage actually, because you can get it to hold the bearing snug. And then as long as it's in the centre of that and you Dremel those bits out, your bearing should push in there okay. You shouldn't need to be forcing it in hard. If you're forcing it in hard, you're going to crack it. So C-hubs, I've done originals as well, but I haven't got any here to show you at the moment. But the original C-hubs are just as original. They should just fit in your wishbones, no problems. These ones I did, these ones are the ZXR type, you see, with the two mounting holes. And they have bearings in these ones. So that's obviously included in the C-hub file if you want to put bearings in. It does kind of help actually, because I've noticed when I've used these before, it's such a nice clean steering to have that on there. The parts just they move so freely. I have done another one of my attempted videos, which I will cut up, which would tell you which bearings these are. I think they're a 4mm internal diameter, 8mm external diameter, and they're 3mm thick. Any more than 3mm thick, they'll stick out the top. Your parts won't fit. So there you go. And there's one that I've put on the front wishbone ready to go. Using that mounting hole, just because I can. This is a 3D printed arm. It's up to you which way you print it. I've got a textured plate on at the moment. The textured plate obviously gives it this nice sort of texture on the top. Some people don't like it. I prefer the 3D printed look. So these are ones original. This is an original arm, and this is my 3D printed one. So if I just move all of this stuff out of the way, you should be able to see. So relation to the original, it's exact. 3D printed one is exact. It's an exact copy. It's got just a couple of little things about it. So you're going to print this flat, obviously. When you print it flat, it means all your holes are going to be slightly squared. They all have support structure in, you have to push out. Now it is slightly thicker, as you can see, because although measured and exactly right, and it does fit perfectly, they print slightly thicker. I think if you print a support structure underneath it, it will be exactly the right thickness. But because I haven't printed a support structure underneath it, it seems to me have meant that the plastic underneath here is slightly saggy. I don't know why. It's come out slightly thicker. But yeah, as you can see, I have measured it exactly. They do fit perfect. They fit spot on. You're going to need to tap these 3 holes here all the way in, because that's where your suspension bottom mount goes. Tap them all the way in. Run a 3mm drill bit through these, all the mounting points, front and rear. Or, you know, I don't think you should have to force a shaft through that. If you're forcing a shaft through it, you may well crack it. So if you've got the time, the money, go on Amazon, find yourself a 3.1mm drill bit and run a 3.1mm drill bit through each of them, make it slightly looser, which is what I've done. Same with the rear. I mean, this is an original rear. As you can see, it's a factory rear. And then my rear is there. It's an exact copy. There you go. Now, my factory rears have 2 holes in, different to the original factory rears. That's because one of my cars came with these slightly different rear arms. I've asked someone who's in the know on the ZXs and ZXRs, and they said that the mould was later, so it had these extra holes in it. So my rear arms have these extra holes in, whereas these are obviously the older original mould from the factory, and they don't have those holes in. But yeah, it shouldn't make any difference at all. I think, don't hold me to it, but I think they are for an anti-roll bar. But there you go. So the only obviously parts that you're not going to be able to 3D print, although I have included them in the files, I didn't include them in intend you to 3D print them, but I mean, you possibly could do. LA7, which has a one-way bearing in it. You can 3D print this from my files, but I don't know. You can probably get. I've got one-way bearings that would fit in there. Whether it would be any good or not, I don't know. I imagine 3D printed part would be no good in there. That's why this is aluminium. This again, this one here. I think this has got a one-way bearing in it, so that'll be LAW4. So LA6 doesn't have a bearing in it. It's just a straight flat piece. So there's 2 all my files. I think there's LA6 is in there, and it doesn't. If you look at the end of it, it's just a 3 or 4. I think it's just a 4mm hole. So you could possibly 3D print that again, but whether it'd be any good or not, made out of plastic, I don't know. How accurate you'd be 3D printing it, I don't know. Also, these are like I said, these are aluminium. So they're the bits that I buy. These every now and then one will come up for sale somewhere in the world, and I'll buy it. I think this one's come from Spain. This was in a collection of parts. This is the bit that goes on your spur gear at the end there. They're hard to get hold of. If you've got a lathe, you could probably make one. It's not that difficult. But I have included a file in these parts for free that anyone who's got a CNC machine could CNC that. I've also done this as well. I've also recreated this in CNC. So this is an odd little part which goes on top of some spring washers here before the nut goes on, that holds obviously your spur gear and everything in place. I've included those files. I've included them for free on CG Trader because I personally don't have the ability to make those. Somebody else might, in which case feel free to knock out as many as you like. Anyone can download that file for free, and it's got all of these in it, including the lay shaft as well. So somebody with a CNC machine could probably make the stainless lay shafts. It's beyond me. That's all I'm saying. Hence the files are there for free. Perhaps if you made some, you can make a few, put them up for sale. I've tested all of these parts. I've tested everything that I've made, and it all fits together. Now, whether it works or not, all put together, as in whether you could actually use it without it falling apart, I don't know, because I've never actually driven one of the cars that I've made, but they do seem fairly sturdy. The other parts that you're not going to be able to get, these drive shafts, you can get them from JC Concepts only. I have tried finding similar on Aliexpress, and there's just nothing. Nothing else that has a similar drive shaft. These are actually original Kyosho ones, but the J Concept ones are really, really good. I've now bought 3 or 4 sets from J Concepts, and he's not asking a lot of money. They're 30 quid for a pair of drive shafts for the front. Rear drive shafts. I'll tell you what I'll do. I'll cut up the video I made before, and I'll put all those parts at the end here so you can see where to get all the bits that I've used to create this car, which is my 3D printed ZXR. It's completely 3D printed, this one. There you go. So I'll put a link to all the bits what I've used in there. I've done my own rear wing mount for this, which is partly 3D printed, mostly CNC cut, but I've now also done 3D printed sections where the bits where the wing mounts on there onto, I've made them out of plastic now, 3D printable. So you could 3D print all of it really if you wanted to. So you've got an adjustable rear wing. So there you go. And then I suppose after that, the other bits you've really got to find are your rear drive cups and your differentials, a couple of screws and nuts and bolts, and obviously some shock absorbers. Shock absorbers are, so I'm told, 85mm on the front, 95mm on the rear. I think you could possibly get away with slightly different, like maybe 95 and 105, but we'll see. Give it a go. To save you the hassle, I've discovered parts that will fit and will work. You may have to modify them slightly, but you can find most of these parts on Aliexpress or eBay or locally. So stuff like the OT4 Kingpin, these are hard to get hold of. But if you look here, this, which I found on Aliexpress, will do the trick. It's got slightly longer thread, that's all, by probably a couple of millimeters. All that means is that the drive shaft, when it's going round, will possibly catch the end of the screw. But all you've got to do is run the end of this on a grinding stone, take off a couple of mil, and you've got exactly the same thing as OT4, exactly the same. So these here, I'll show you, I've done printouts off Aliexpress. That's these M3 by 4 by 10mm hex button head incision kingpin shoulder screws, and that's what I've got. And they send you a whole bag full. So, like I said, all you have to do is just shave the end off of that there by about 2mm, and it will fit. The other one to OT4 that people struggle with are these LA21 kingpin. And these fit in the bottom of the C-hubs. They fit in the bottom of these. Or if you want an original, there's an original one just here. So you see the bottom. The bottom is actually quite a bit thicker than the top. So that's what you need these for. So these LA21s, you can use this. Much the same situation as I showed you with the OT4. The only difference is the screw thread is slightly longer, and you need to shave probably 2mm off this to make it the same length as that. And the head is slightly bigger, but that it won't matter. But there's enough ground clearance that it won't matter. So just shave a bit of the screw thread off, and you've got an LA21. And those ones you can either have these ones here, which are a hex head screw, or you can have these ones, which I used on the car that I've recently made. So these are the ones I chose down there, are 4 by 6mm, M3 by 4. So it's an M3 thread and a 4mm shaft, and they are size there is D4 by 6. £3.27. You get a whole bag. There you go. So you should be able to search that on Aliexpress, and that'll find you those screws. So I'll show you on the car that I have. Excuse the mess in here at the moment. As you can see, there. This is my 3D printed ZXR. This one has original parts in the top. But yeah, so Aliexpress is your friend with those. And the same with drive shafts. So drive shafts, these are original rear drive shafts. So from centre of the pin to the centre of the pin is 62mm on the originals. And from the end of the shaft to the end of the shaft, 68mm. These ones from Aliexpress, they're 65mm centre of pin to centre of pin, and 70mm end to end.
And the reason why it's significant these are slightly different is because I'm using ZX differentials with these. And as you can see, these drive shafts, they do fit. They're not too long and they're not too short. They stay in, they don't fall out. So as you can see, everything, you've got full range of suspension movement, no issues. So those drive shafts are on Aliexpress. And like I said, they may or may not work for you depending on what differential you're using. But they are the 70mm length, and this is how they measure them on the website. As you can see, 6mm ball, 10mm across the pin, and it's 65mm pin to pin and 70mm end to end. £2.28, you get a pair. If I were you, I would start looking at these, because these are also in the TF2 Spider, I think in the TF3 Spider. They're also Optima, but what you can do, and this is something I discovered by accident actually, the casing, and this is why I've included the casing in the parts. I've designed this casing, CAD designed it, and have uploaded it into my CG Trader. You can actually fit Optima internals in these, which is these parts here, OT28. OT28 will fit inside the LA1 gearbox differential parts inside that. So if you've got LA1, which is this, there's the standard slipper type piece pulley, and then here I've got a couple of these in here. You get left and right halves, but these are what's in the TF2 Spider or the Lazer ZX, and they will fit the ZXR no problem. And then all you need obviously is you need your drive cups, which are these here, which, you know, these are original ones, hard to get hold of also unless you have an alternative, which is what I'm going to get to next, because if you look at my 3D printed ZXR, I have silver ones and they work, and those are also available on Aliexpress, and they are these here, available on Aliexpress for £1.60 a pair. Red Cat Racing, Drive Cup B02016, will fit. Cheap as anything, perfect. These are the rear gearbox drive belts. These are a standard drive belt. It's not special. They're not only made specifically for the Kyosho Lazer. They're actually this here, which is the if you can see there, 3M is the type of is the teeth, the spacing, size, and all that. So you need a 3M 177-4. The 4 is the width of the belt. So 3M 1774. So it's 177mm long and it's 4mm wide. And that's the £2.04 for a drive belt. So I bought a bag full, obviously. You get two there for £2.04. Like I said, I mean, I haven't tested these, so if you take this advice and you take this on board and you buy these, I hope they work for you. But I don't personally see any difference. They fit in the belt, they're the right size, they're the right width, but I haven't driven the car with this in, so I honestly have no idea whether it'll fall apart. It doesn't feel like it's going to fall apart. They feel pretty good, in all honesty. But that's the rear gearbox drive belt. Now, we also have the main drive belt. So if I show you firstly, I have a very old one here. This is an original. That's an original belt. And as you can see, it's ancient and it's worn out. Very slightly stretched too. Now then, this this is exactly the same. This is a brand new one, and it's an HTD 537-3M. I cannot honestly remember whether I bought these from the same place. I don't think the two belts came from the same store. So this is the longer belt. HTD 3M synchronous belt. Now, originally, it's a 4mm belt. This one that I've bought, and that you can see there, is slightly thicker. It's a 5mm. So it's a 3M 537, and it's 5mm wide. So there's plenty of different options in there. You see, when you go on the website there, this section here, you can choose different widths. I chose 5mm because it's the thinnest one they did on that belt. It needs to be 537mm long, but 5mm was the only width that I could find. I couldn't find a 4mm, but I have to say it doesn't seem to be a problem. So if you take this belt, obviously it's better for me to do this than you buying the parts and then finding out it's no good. But as you can see, if it focuses, it fits. It does fit. It fits in there. It runs perfectly fine. So I don't see an issue with it. I mean, you could buy yourself a good stock of belts for a few pence. You know, it literally costs so little. You could probably just buy a whole bag full and never worry about having a drive belt ever again. So yeah, again, that is what was it, £6.25. I can't honestly remember whether you get more than one belt in there. I think you get more than one belt in there for £6.25. Can't honestly remember. But, you know, you've got to admit, that's a pretty good price, considering what you would pay for an original Lazer ZXR belt with the, you know, the Kyosho packet on it. I'll show you these first. So this one is 99% original. I think it's only missing 2 original parts, which is one of those is the front bumper. The rest of the car is original. It's got the shorter front shocks on it though, and this is, I've custom made this as a brace to protect the tower and the front gearbox. But it's pretty much original car. This one is completely 3D printed and CNC cut, with the exception of, like I said, 1 or 2 pieces that you just can't get and you can't make without a 5-axis CNC. So these are my 2 latest cars. So I'll just take the bodies off and I'll show you these chassis. So this is an original. That's an original chassis. Please excuse the dremeled bits. That was done for battery straps many years ago. I could go back and change it, I would do. But that's what the original chassis looks like. That's a Mark II. Now this one is the one that I have 3D printed and CNC cut, and that is a CNC cut chassis, Mark II, that I've done. Now I know I've said it before on this video, I'll say it again, that the angle of the carbon fibre is a little bit off. Main reason, I'll try and put the photograph in here, the CNC router I had was a beginner, just a beginner router, and it was too small. So what I did was I did the chassis at an angle across the bed, and that's what the outcome was, unfortunately. But as you can see from this photo, there is actually a new CNC router just arrived yesterday. So the next one I do will be a sort of a pinkish red colour chassis, and the carbon fibre should be the correct way. But what I've got here is these are cutouts of the design off of Fusion 360. So I did this is the ZX or Mark 1 chassis. As you can see, that, hang on, they're quite different. They're quite different, the Mark 1 and the Mark 2. And there we go, we'll put them both together there, look. They are quite different. So it's not just that this has obviously got 7 cutouts in for cells. It's that the screw holes are in seriously different places. So if you note those ones behind there compared to the ones here, these are further back. Also here, and if you note those over here, we have 2 extra holes. So as I said, both these cars are Mark IIs. So this is a Mark II chassis. The Mark II chassis only had 6 holes, and they were set further back on the chassis. So this is my design, and as you can see, it's perfect, fits perfectly, it's exact. So obviously when I've cut it out, that's exactly how it's come out. It's an exact chassis. So this is a file that you'll be downloading if you download the chassis file, or if you download the whole car pack, which has got all this in anyway. It's got all the chassis and stuff in it. It's exact. It's an exact copy. So what I had to do to do this, whether it matters to you or not, was I had to do this, make this, print this out, cut it all out. Probably 6 or 7 times I had to cut these out and then adjust the holes to make sure that these holes were in exactly the right place for the screws on this chassis. And then once I'd got it done and I was happy with it, I then CNC cut this one and then overlaid that over this one, and it showed that it was exactly the same. So yeah, you can study both of those there, and you can see if you buy the car pack or you buy the chassis pack, that's what you're getting. You're getting that, which obviously would work on that perfectly well. So as it happens, it works so well that all the other parts that I've made fit perfectly on this completely 3D printed and CNC cut car. Like I said about those the parts, here we go, hub parts. These are Aliexpress alloy ones. Didn't have to use those, could have used my own ones. And at the rear, as you can see, are my plastic hubs. This car also has, as it is completely 3D printed, a polycarbonate spur gear. This is a carbon fibre washer, and everything's carbon fibre. So there you go. This is my wing, yes. This is my wing design. Fully adjustable, as you can see. That's how I've done it. If you look at that and you are trying to recreate that, you should be able to do it from that. As you can see, everything works, everything fits. Difficult to do with one hand, but everything works and everything fits. Never going to get any grip on here to push. Can't really show with one hand. Belt goes round. So yeah, if that's what you wanted to do, if you wanted to 3D print a car, it is totally possible with these files. That's the steering. There we go, take a good look at that. A large spacer at the bottom, smaller spacer at the top. Space for bearings in here as well. So yeah, I suppose there's not much left to say really, other than you just do a bit of model making, don't you? You do a bit of model making and enjoy it. You can see through this clear polycarbonate, you can see the roller in the gearbox there, the little brass roller. There's another one over here down the bottom inside there. If you're using 3mm carbon fibre for this and 3mm carbon fibre for this, you have to note that these screws won't fit though. You have to buy, these are aftermarket screws that I've bought, because the originals won't fit, because you'll be 2mm too wide. So your screws will go through to the end of this part of the gearbox, but they won't actually meet the motor plate. So you'll need to buy longer screws for that. And obviously things like this, where you're mounting your shocks to, you'll find that your screws are probably not going to be long enough for that if you're using 3mm carbon. I use 3mm carbon. Just thought stiffer's probably better. I might be wrong. I don't race them, so I might be wrong. I've left this without speed controller at the moment. I'm going to put a speed controller here. I've left it without so you can see how everything fits. This is one of my Aliexpress drive belts. As you can see, works. You know, it all works. It does. Well, I can't really push it on here because it's shiny, but as you can see, it does work. Yeah, it does work. So yeah, all of these bits, they do work, they do fit. Just take care printing it, take some pride in it. And obviously if everything comes out okay off your printer, then you should be able to screw it together like I have done. Again, I haven't tested it. I'm probably not going to test it because I really don't have the time. This is my hobby room. It's full of 3D printers and lots of RC cars to repair and build. And now the floor is starting to get covered in them as well. So yeah, I've probably not really got time to go out there testing driving, but somebody else could. And then write up here whether they managed it and whether it worked for them. So yeah, there you go. Lasers. There's my other one. That's more of a ZX. So in the shock tower file, you'll find that the ZX ones are there as well. That's a ZX shock tower. Yeah, everything fits that one as well. It's got a ZXR body on it. But I didn't write ZXR on the side of it. I just put laser on that one. But the one last thing I was going to do, I've also done a window mask, which is this here. You might want to cut it up, but I just thought it might help somebody. It fits in here, as you can see. So I'll include this file as well with it all. I think I'll put that one down for free on there. You can just download it and then, you know, you cut it out of masking tape or whatever, and you've got a window mask, haven't you? So there you go. Sorry about rambling and rabbiting on for so long. I just wanted to make it easier for whoever wanted to create one of these. This one's sort of 80% 3D printed, this one's 100% 3D printed, so it's totally possible. I just hope that someone else finds some use out of these files that I've made.